Now we will see what's the actual meaning of subspace and the span. Subspace is a smaller space within a vector space. That itself is a vector space. That means all the subspaces, they are the vector space. We will see what's that. If I have a vector space V, okay, I will represent this as like this. This is my vector space. Then the subspace is always, it comes inside this vector space. That means it is a subset of the vector space. This we can call as a subspace. Subspace is a subset of vector space. In order to call the given set of vectors as a subspace, it has to satisfy the three conditions. That's here you can see that the zero vectors and the u and the v such that u plus v belongs to the subset W, and if u belongs to the subset W, then some scalar into u also belongs to the subset W. That means here we are considering the main vector space as V. Okay, here we are considering the V. Then let W be one subset of V. W is a subset of this vector space such that this W belongs to V. Okay, then we call this W as a subspace of V, that's the vector space, only if it satisfies the three conditions. That's the zero vector or the zero, it should, you can see here the zero vector that should be in this subspace. That means the zero vector belongs to W. And if we take any two vectors, that means this W means the subspace is a collection of some vectors. Let's say we will take this as a U vector and V vector. Then this U vector plus V vector, that should belongs to W. This one is the new condition. Remaining these two conditions are the previous whatever we defined for the vectors, and any scalar C into this U vector, this also belongs to the W. These three conditions this has to satisfy, then we call that as the subspace. Then what is the span? Span of a subspace, what is that? Here you can see this is our vector space. Okay, then vector space means it contains lots of vectors like v1 vector, v2 vector up to vn vector, which belongs to this vector space. That means this sphere is a one vector space. It contains lots of vectors like v1, v2 up to vn. Then if we multiply a scalar, something a1, a2, these are all some scalars, then this equation a1 v1 vector plus a2 v2 vector plus dot 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 until an vn vector, this we call this as a linear combinations. So this is one linear combinations a1 v1 vector. Okay, like this set of all the linear combinations in this is called as the span. We will see with one example. Here I have v1 vector is equals to 2 1 minus 1 0 2 2 and v3 is equals to minus 1 minus 1 minus 1. That means these are our some three vectors in the vector space. Okay, now let's see whether these three vectors, the set of these three vectors will form a span or not. For that we need to represent this as in the here as the definition shows set of all linear combinations. So we have to represent this in a linear combinations. That means the span of these three vectors equals to A into 2 1 minus 1 plus B into 0, that means B into vector 2 plus C into vector 3. You can see that. So if we multiply, it becomes it becomes 2A. I think you know, if any scalar is there and here is some vector 1 2 3, then it becomes 1A 2A and 3A. Like that we need to simplify this, so it becomes, here you can see that it becomes like 2A minus A plus 0 2B 2B plus vector minus C minus C minus C. Then if we simplify this, it becomes 2A minus C, A plus 2B minus C minus A plus 2B minus C. Of course, we know that that is the span of the V1, V2, V3. This is the span. This span of this given vectors is always a vector space. It should be always in a vector space. That means it is a subset of a vector space. Actually, the given vectors are always in vector space, so that's not the main thing. The main thing is that the span of any vector, that should be a subspace. That means this should be a subspace. But these vectors are there, no, that may not be the subspace. That means the span should always be a subspace. But these vectors here, if I define my subspace as all the vectors such that this is okay, we will consider this as x1, y1 and z1, such that x1 into y1 into z1 should be greater than 0. If we consider like that, then this v1 here, x1 into y1 into z1 is not greater than 0. That means that's minus 2. That means this v1 is not a subspace. But if we consider the span, then here I am not sure whether we will get this span of v1, v2, v3. That means if we bound that condition, then this span 2A minus C, A plus 2B minus C, minus A plus 2B minus C, this value, if we find out, then if it is greater than 0, if it satisfies that condition, then this span is the subspace. Always this span will satisfy that. So the span is span of any vector is the subspace. The vectors in the span that may not be contained in the subspace, but the span of any vectors is a subspace. I think you understood this. Now we will see some questions regarding this, some basic questions. If I have some vector v1 equals to 15 and 1 and v2 equals to 0 and 6, then what is the span of these two vectors? Tell. The span of this vector is 15a and here the span of v1 plus v2, okay, v1 plus v2, that is equals to 15a and here a plus 6b. This is the span of v1 plus v2 equals 15a and a plus 6b. I think you have understood now the spam and what's the subspace. Thank you.